You can remember yesterday. You cannot remember tomorrow. You can drop a glass and watch it shatter. You will never see shattered pieces spontaneously reassemble into a perfect glass. Ice melts in a warm room. A warm room does not spontaneously gather its heat and become ice. Time moves in one direction, forward. But here is the strange part. The fundamental laws of physics do not care about direction. If you take Newton's equations of motion, Maxwell's equations of electromagnetism, or even the Schrödinger equation in quantum mechanics, they work perfectly well whether time moves forward or backward. Mathematically, they are time symmetric. Replace t with t, and the equations still hold. At the microscopic level, nothing in the laws of motion insists that the future must differ from the past. So why does your experience of time have direction? Why does entropy increase? Why does the universe age? To answer that, we must understand entropy properly, not as disorder in the casual sense, but as probability. In the 19th century, physicist Ludwig Boltzmann made one of the most profound conceptual breakthroughs in science. He connected thermodynamics, the study of heat and energy, with microscopic particle motion. Before Boltzmann, scientists knew the second law of thermodynamics: entropy in a closed system tends to increase. But they did not fully understand why. Boltzmann proposed something radical. Entropy is not a mystical force. It is statistical. He expressed entropy with a simple equation engraved on his tombstone: S x k log W. S is entropy. W is the number of microscopic configurations consistent with a macroscopic state. In simple terms, a highly ordered state can exist in very few microscopic arrangements. A disordered state can exist in enormously many. Imagine a deck of cards. There is exactly one arrangement we call perfect order, but there are astronomically many shuffled arrangements. Shuffle the deck randomly, and you almost certainly get disorder. Not because disorder is forced, but because it is overwhelmingly more probable. Entropy measures this probability landscape. Now apply this to physical systems. Air molecules in a room could, in principle, cluster into one corner. The equations allow it, but there are vastly more ways for them to distribute evenly than to cluster. So they spread, not because they must, but because probability dominates. Entropy increases because systems move toward more probable configurations. This statistical tendency gives rise to the arrow of time. Time moves forward because entropy increases, not because physics demands direction, but because probability does. Now, here is the deeper question. Why was the early universe low entropy? Because without low initial entropy, there would be no arrow of time. If the universe had begun in maximum entropy, total equilibrium, nothing interesting would happen. No stars, no structure, no life. The early universe, shortly after the Big Bang, appears to have been extraordinarily uniform and low in gravitational entropy. This is sometimes called the past hypothesis. The arrow of time exists because the universe began in an extremely special state. As it expanded, entropy increased. Stars formed by gravitational collapse. Stars burn fuel. Energy disperses. Galaxies evolve. Black holes form. Entropy grows. Time is not flowing like a river. Time's direction emerges from this entropic gradient. You remember the past because records exist of lower entropy states. You cannot remember the future because it has not yet crystallized into record. Memory itself is a physical process. Neural activity consumes energy. Synaptic changes dissipate heat. Every act of remembering increases entropy. Irreversibility is not fundamental. It is emergent. At the microscopic level, reversibility holds. At the macroscopic level, probability overwhelms reversibility. Now bring quantum mechanics into this carefully. The Schrödinger equation governing quantum evolution is time symmetric. But when quantum systems interact with environments, something happens. Decoherence. Physicist Wojciech Zurek showed how interaction with environment causes quantum superpositions to effectively become classical outcomes. Information spreads into the environment. Entropy increases. Irreversibility emerges from entanglement. The arrow of time appears when information disperses irretrievably. Once information about a system spreads into countless environmental degrees of freedom, reversing it becomes practically impossible. This is why broken eggs do not spontaneously reassemble. The information required to reverse the process is dispersed into the environment. Now pause and consider something subtle. Time's arrow is tied to information, and information is physical. Claude Shannon, in the mid-20th century, developed information theory. Shannon entropy resembles Boltzmann entropy mathematically. Information and thermodynamic entropy are deeply connected. To erase information requires energy dissipation. This was formalized in Landauer's principle. Erasing one bit of information has an unavoidable thermodynamic cost. Information processing increases entropy. Your digital devices heat up because computation dissipates energy. Your brain heats up because cognition is physical. So time's direction is linked not only to heat, but to information flow. The universe evolves towards states of higher entropy and greater information dispersion. Now let's bring this to experience. Why does time feel faster as you age? There are psychological explanations. Fewer novel experiences, more pattern repetition. But there is also a structural interpretation. When you are young, everything is new. Novelty creates dense memory encoding. As patterns stabilize, fewer distinct markers exist. Time feels compressed because fewer new configurations are formed. Entropy increases. Novelty decreases. Structure stabilizes. Time perception shifts. This is not purely thermodynamic, but it echoes structural logic. Now consider aging. Aging is entropic accumulation. Cells experience molecular damage. Repair mechanisms weaken. Proteins misfold. Genetic mutations accumulate. Biological systems are dissipative structures. They maintain local order by exporting entropy. But maintenance is not perfect. Over time, entropy wins. This is not pessimistic. It is physical. But within that entropic flow, local order can persist remarkably long. Stars burn for billions of years. Living organisms maintain order for decades. Human civilizations persist for millennia. Order exists within entropy, not outside it. Now here is where philosophy becomes necessary. If time's arrow is entropic, then time is not a fundamental force pushing events forward. It is an emergent statistical property. This challenges intuitive metaphysics. We imagine time as flowing, but physics suggests time may not flow at the fundamental level. Some interpretations of relativity suggest a block universe, where past, present, and future coexist as a four-dimensional space-time structure. Physicists like Hermann Minkowski reframed space and time as unified geometry. In this view, the arrow of time is perspectival. It emerges from thermodynamic asymmetry. This does not mean the future already exists in a mystical sense. It means that our experience of flow may not be fundamental. It may be cognitive. Your brain constructs a moving present because it processes sequential information. The sense of now is tied to neural integration windows. You experience time because you process entropy gradients. Now think structurally. If entropy defines direction and entropy is statistical, then irreversibility is not moral. It is physical. Regret does not reverse entropy. But structure can reorganize locally within entropic flow. This matters because many people interpret time as enemy, a force-stealing possibility. But entropy does not eliminate structure instantly. It allows temporary islands of order. Life is one such island. Consciousness is one such island. You are not fighting time. You are participating in energy flow within time. Local decreases in entropy require energy input. Exercise requires energy. Learning requires energy. Emotional regulation requires energy. Transformation requires energy. Nothing reorganizes spontaneously into higher order without input. This is thermodynamic honesty. But input does not violate entropy. It redistributes it. When you learn, You increase neural order, but you dissipate heat into the environment. Local structure increases. Global entropy increases. This is how growth is physically possible. Now let's connect this to identity carefully. You experience yourself as continuous across time. But materially, you are not the same atoms you were years ago. Continuity is pattern persistence. Pattern maintained through energy exchange. You are a dynamic structure, not a static object. Quantum field theory already told us that matter is excitation of fields. Thermodynamics tells us that those excitations exist within entropic gradients. Time is not something happening to you. It is something emerging through you. Your body metabolizes. Your brain encodes memory. Your environment exchanges energy. Time appears because entropy increases. Now think about transformation again. Change does not happen outside time. It happens within entropic flow. But entropy does not only destroy. It drives evolution. Stars form through gravitational instability. Planets form through accretion. Life evolves through energy gradients. Complexity increases locally because entropy increases globally. This is subtle but powerful. The arrow of time allows complexity. Without entropy gradient, nothing would change. Uniform equilibrium would persist forever. No differentiation, no memory, no growth. Time's direction makes narrative possible. Narrative requires before and after. Before and after require asymmetry. Asymmetry requires entropy gradient. So the arrow of time is not just decay. It is possibility. Everything meaningful occurs because entropy increases. The same principle that melts ice also allows stars to shine. The same law that ages cells also enables memory formation. Entropy is not villain. It is structure unfolding statistically. Understanding this reframes fear of change. Time does not erase instantly. It reorganizes gradually. And within that gradient, local order can flourish if energy flows appropriately. The universe began in extraordinary low entropy. That rare condition made everything else possible. You exist because the early universe was structured in a way that allowed entropy to increase. Your life is a temporary but remarkable configuration in a thermodynamic landscape. Time moves forward not because something pushes it, but because probability distributes. Entropy increases. Information disperses. And within that dispersal, local structure appears. Briefly, beautifully, meaningfully. The arrow of time is not mystical. It is statistical. But its consequences are profound. You remember the past because entropy allows record. You anticipate the future because entropy permits possibility. And you live in the present because your brain integrates energy flow into conscious sequence. Time and entropy are not separate. They are two sides of the same structural phenomenon. The universe moves forward because it began in an improbable state. And within that movement, structure emerges, evolves, and eventually dissolves. Not randomly. Lawfully. Understanding that does not stop time. But it clarifies it. And clarity changes how you inhabit it.